Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and cagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. In this episode, I interviewed Dr. Pablo Samuel Castro, who's currently a staff research software developer at Google and is working with the Google Brain team in Montreal with a focus on reinforcement learning and machine learning applied to music and creativity. We, of course, talk all about these themes in this interview: reinforcement learning and using AI in creative domains. Pablo is a musician himself, so we talk about and we definitely discuss his overview on using AI to replace or enhance human creativity in domains outside of technical focus. We also discuss how does Pablo approach research problems, his take on research, and his pipeline or approach to working on new problems. This interview definitely has a lot of interesting pieces of advice around approaching research problems. So without further ado, here's my interview with Pablo Samuel Castro. With a quick reminder to the audience, please subscribe to my newsletter if you'd like to stay updated with the interview releases. And if you're a non-native English speaker, please remember to go to YouTube and enable the subtitles for a better watching experience. The subtitles have been manually checked and re-uploaded. So I hope that improves your watching experience. With that, here's the interview. Please enjoy the show. Hi everyone, I'm really excited to have a person from the Google Brain team, Dr. Pablo Castro. Thank you so much, Pablo, for joining me on the podcast.
Thank you for having me. It's a pleasure.
Likewise. Now, I want to start by talking about your journey, how you got interested in machine learning before we talk all about your amazing research and work. Can you tell us at what point did you find your passion for machine learning?
So in undergrad, so Doina Prekop, who became my PhD supervisor, she joined McGill as faculty when I was doing my undergrad. And I think I took the AI course with her. I think it was the first time she was teaching it at McGill. And I didn't really know what AI was before then, but I fell in love with that course. And we had to do like some class. The project was like some 3D tic-tac-toe or something. The project itself, I didn't do very well in the competition, but I just was really interested in this idea of having computer programs learn and adapt themselves to improve. So this was my last year of undergrad. So for my last semester, I was in honors, so I had to do an honors thesis, and I asked Doina if I could do it with her. And so I ended up doing building this neural network to try to improvise in jazz, to build a program to try to learn how to improvise in jazz. I've always been interested in music. So it worked really poorly. It didn't really work at all. Mostly because, so the way I had set it up is I didn't really want to encode rules for what constitutes good melodic lines or not. So here I was being naive, learning about how you train these things. And so I set up the system where I had to listen to melodies it generated and then give it a score of thumbs up or thumbs down. Okay. And so obviously, like, there's only so many of these melodies you can listen to. And I mean, occasionally you get certain melodies that sounded pretty good, but it was probably mostly random chance. But that was just a really informative experience because it showed me how difficult it is to train these things, and like the choice of hyperparameters, choice of network topology, and all that is important. But so I'm originally from Ecuador, and so I came here on a student visa, and I think I don't know if Canada still has it, but I think they do. They had this program where if you got a job in the field that you came to study, then you got a temporary work visa for a year.
Okay.
So I didn't want to have to leave Canada. So I left school and once I finished my undergrad, I went to work for this company that builds flight simulators, like real
Okay.
physical flight simulators for
Okay.
training pilots. And that was a cool job. I worked there for 4 years, traveled all over the world because we worked on, my job was to port code from computers built in the 80s. So these things that are the size of walls into like small Linux boxes. So it was like porting from Fortran to C or sometimes even assembly. And so I did that for 4 years, but then I started getting an itch to go back to school and learn more. And one day randomly ran into Doina on the street and I told her, yeah, I'm thinking of switching jobs or doing something different. And she said, oh, come do a master's with me.
Okay.
So I did. And that's, then I started my master's and continued on to PhD with both Doina Prekap and Prakash Panangaran.
Did you sometimes take the flight simulator for a spin during sometimes in the evening? Would you take it on a spin, maybe do a few?
Yeah. Because I was working on these really old systems, there was no multi-threading. So when you had to, we did have to compile databases and things like that, and sometimes it would take 3 hours. So
Wow.
when you start compilation, there's nothing you can do on the simulator at that point. You just have to wait. And so we worked at night because we wanted to use the simulators when nobody was training on them. So when it was compiling, I'd go and fly some other simulators and sort of learn how to fly planes. And the most difficult one and also the funnest one was a helicopter. That was really hard to fly.
Interesting.
But towards the end, I could sort of take off and land in a heliport in Manhattan. But I couldn't do that anymore. This was many years ago.
Are you confident that you can do it in the real world?
No, that's what I'm saying. Like I don't remember how. Have a rough idea for how you would do it, but I would not even try.
Okay. Now, coming back to your journey, why did you decide to take a PhD? And I believe you specialize in reinforcement learning. Usually, people have a salty pick about it. What are your thoughts about it? Because people usually believe that it's not ready for the real world. Would love to hear your thoughts about it.
Yeah, so I mean, when I started my master's, I guess I picked my supervisors over my topic. So at this time, when I started my master's, it was 2005. So machine learning still wasn't that popular. Not many
Yeah.
people really did this stuff. And so I read when I was in my job. Part of the reason I got interested in it is because I started reading the Russell and Norvig book, the AI Introduction.
Yeah.
And I actually was really interested in evolutionary algorithms that I just
Okay.
found super fascinating. And so I went to see Prakash and Doina. I had taken undergrad classes with both of them. And Prakash is a very math heavy guy. And he was like, oh no, I'm not doing any evolutionary things because you can't prove things with them. It's really hard to prove things. So, but I wanted to work with them. So I said, okay, I won't do that. And so I ended up picking what they were interested in, which was metrics, state similarity metrics and Markov decision processes for reinforcement learning. And I got really fascinated by that because it has a lot of really cool math, and I learned a ton there. And so that's kind of why I ended up studying that stuff. So I didn't necessarily, I picked it more because I found the math interesting. At that point, again, this was before the deep revolution. And
Yeah.
so people weren't really thinking about how are we going to apply it in the real world. There was still like an academic interest and sort of working towards hopefully one day we can use this, and here's all the theory that we've built up so far, which is what's happening today. Like a lot of the theory that was built beforehand is being used nowadays with deep networks, and a lot of the old ideas are being resuscitated now with deep networks. But when I graduated from my PhD, I did have a hard time finding a job. I wanted to be in academia, and I wasn't able to find anything. Especially reinforcement learning, like not many people were interested in that at the time. And so I left academia for a while, for 5 or 6 years, because I joined Google, but as a software engineer, applied software engineer in machine learning, but applied. And I remember Andrew McCallum, who's a prof at UMass, came to visit my office in Pittsburgh once, and I met with him. And I told him I do RL, and a quote that he said that still stuck with me until now is, reinforcement learning is a solution in search of a problem. And I think at that time it was still the case. Nowadays, I think it's less true. That statement is less true. It's just we're seeing a lot more evidence that it can actually solve very, very challenging tasks. The key is being able to pick the right tasks that you can tackle with reinforcement learning. So for instance, something where safety isn't super critical, and I think this is in general for neural nets, because you don't have this level of interpretability yet with the algorithms that you end up training, or the models that you end up training with these deep networks. But I do think the time is right to start putting these things into practice. And there are a lot of efforts in industry outside of academia that are working towards this. Some of it is not necessarily in a like user-facing product, but maybe more as an analysis tool for understanding dynamical behaviors and things like that. So, for instance, I'm I guess consulting or helping the Bank of Canada, which is the federal bank here. They're working on this project to use reinforcement learning to understand the dynamics in high-value payment systems. So these are the payments that happen between large banks. So that's a lot of money, and it's regulated by the Bank of Canada. And so they are interested in seeing if reinforcement learning can potentially be useful for understanding these dynamics and provide more realistic simulations to sort of help regulate things more. So this is something where it's not, RL isn't in the wild in the sense that people are interfacing with it directly, but it's still being used in practice for something that does affect people.
Do you agree to the viewpoint that I believe, for instance, OpenAI is following, that you can create a RL system and then follow it to generalize to bigger issues such as the OpenAI 5, for example?
Like that will eventually generalize to other systems?
Yeah.
I'm very skeptical of that. I think if you look at that, if you look at AlphaStar, there's a lot of inductive biases that get put into the architectures that they use and the design choices they make, which is good. I mean, you do get a lot of ideas from that, but it's still very specific to the tasks that they're trying to solve. So for instance, I'm not as familiar with OpenAI 5 because I don't think they've really released a whole lot of details on what they did there. But for instance, AlphaStar, I saw Ariel give a talk about this, and the architecture they used is highly tuned to the StarCraft problem. It's a very complex problem, and they've gotten a lot of really good science out of it, but the architecture they ended up using is very specific to that task. So, I mean, these are all advances, but will that AlphaStar then generalize to other problems? I doubt it. So I think, I guess, one step towards that direction is, I think what it's called, mu0 from DeepMind, where because before, like AlphaGo and AlphaZero, they all still encoded the rules of the game into the training process. But
I'm not sure I remember.
Okay, so mu0, I think, it has to learn the rules from scratch. So that I find is more of a general purpose model.
Makes sense.
But again, there's still some implicit biases in there, in the sense that you're still assuming you have access to a simulator, which is a game that for the most part, it's fully observable, your system, which is not always the case in real world systems. So there's a lot of, RL is special in the sense that deep networks are like all the craze nowadays, but deep networks are just a part of RL. There's all sorts of other things and important design choices and algorithmic choices that surround these deep networks that make or break RL algorithms. And some of these are very sensitive to the environment or the task that you're running them on.
Makes sense. Now, shifting gears towards your journey at Google, I believe you started applying machine learning as a software engineer, then you transitioned back to research. Can you tell us more about your journey and the transitions over the years?
So I joined Google as a software engineer in ads. So I was doing machine learning in ads, specifically building models to predict click-through rates. So those text ads that you see when you do a Google search and you see some text ads show up, those are going through an auction. So advertisers place bids, they create their advertisements, and there's this gigantic auction that happens that uses a whole bunch of signals. One of the most important signals is the prediction of whether the user will click on it or not. And that prediction is coming from a whole bunch of other signals, like what the user is searching for, the geography, those types of things. So that was a really cool job. I really enjoyed it. It was fully applied because it was really building these models that would then get deployed as part of this auction. So I really enjoyed that, but this was in Pittsburgh. I was there for about 4 years doing this, but then we wanted to move back to Canada. My wife is from here, from Canada, so we have family and close friends here. And so I transferred to the Montreal office, and it was funny because the year before we transferred, I came to speak to the site chief here in Montreal, and I said, I'm doing machine learning in Pittsburgh, and I'd like to continue doing machine learning here. And he's like, oh, there's almost no machine learning in Montreal. There's no machine learning in Montreal. In Google at that time, there was no machine learning.
Okay.
This was just like 4 years ago. And so 2 years after that, we had the brain team, we had DeepMind. So it was pretty funny how quickly things changed. So I transferred to Montreal, and I was lucky that Chrome had started this team that was going to try to do machine learning for Chrome, and I joined that team.
Okay.
So there I was mostly building back-end infrastructure, so to be able to serve these models quickly, and it was for auto completion and suggestions and things like that. So I worked on that for a year, and then Brain opened up, and I was lucky enough to be. So I wrote Hugo La Rochelle, who was the manager at the time, and I was lucky enough to be invited to join.
Awesome. Now, can you tell us what does a day in your life currently look like? What tasks are you working on, and what research ideas are currently of interest to you?
So my days are very varied. My office is in Montreal, which is where I am right now, but I actually live in Ottawa, which is 2 hours away. So I work here in the office about 3 days a week. So that means getting into the office. And so right now that it's winter, that means I cross-country ski from my house to the train station. So that's like a 45-minute thing. And then I take the train for 2 hours, and then I get into the office. I have some hours here, and then the same in reverse. So 2 hours back, and then 45-minute cross-country ski. So that is one day. Sometimes I work from home, and then it's just like I wake up early and do work, and then I pick up my kids from school, and then my work is over. But more specifically, what I work on a day-to-day, again, is highly varied. So I like to have a lot of projects happening at once.
Okay.
And they move at variable rates. So I do a lot of work in reinforcement learning, but I also do a lot of work with creativity, like machine learning and creativity. And so I have projects, like multiple projects on both these fields. And typically I prioritize, so for instance, ICML deadline just passed. So we had a paper we were working on, 2 papers that we were working on for that. And so that took priority. So I put everything else aside and just worked on that. And now that that's done, these projects that I had left at one side, I'm going to pick them up again. And then also, like, if I'm working on one main project, sometimes like these experiments take hours or sometimes days to run. And if everything else is ready for that, when you kick off the experiment, then like I don't want to sit around twiddling my thumbs. So then I switch to another project, like second in priority, and work on that for hours or days. So what am I specifically working on in reinforcement learning? I'm actually working again on what I did in my PhD. So looking at these state similarity metrics.
Okay.
But so I just presented a paper at AAAI where I developed this method for approximating these metrics with neural networks. So these metrics have some nice theoretical guarantees, but they're very expensive to compute. And so they've been, I mean, when I was working on my PhD, it was mostly restricted to grid worlds and small toy environments like that. But what I was able to show with these networks is that we can approximate them pretty well with the neural networks, and it allows us to extend them to very large state spaces like Atari, or even continuous state spaces.
Yeah.
And so I have, that's one of my main projects right now, is looking at these metrics and how we can extend them and how we can use them in practice in reinforcement learning. Because up to now, they've been mostly used either as like theoretical reference. So because they have these nice theoretical guarantees, if you can relate your algorithm to these metrics, then you might be able to get some theoretical guarantees. Or the algorithms that use these metrics, I have some papers with that from a long time ago, they're mostly restricted to toy domains, and they wouldn't really work in the large environments that we work on nowadays. So that's one thing I'm looking at, and it relates to another thing, sort of larger theme that I'm very interested in right now, and that's representation learning for reinforcement learning,
Okay.
or how we can try to learn representations that are useful for reinforcement learning in a way that goes beyond the single task. So generalizable or transferable representations.
Okay. Um, Now talking about creative AI, are you trying to automate yourself because you have a passion for music as well? What tasks are you working on in that direction? I know you put out very interesting intersection of I think it's generative networks and music. Can you tell us more about that?
Mm-hmm. So definitely not trying to automate myself. I've been playing music for longer than I've been coding, and
Okay.
it's one of the activities I've been doing the longest in my life. And so I do not want to stop doing that. My interest in this space is really to develop the next generation of tools to enhance or augment musicians or artists. And in particular, I'm really interested in how these tools can be used by quote unquote expert musicians. So I've been playing piano for like over 35 years, and
Wow.
it's I know how to navigate uncomfortable space as well in piano. I improvise, and so I'm fine being thrown in like difficult chord changes or things like that because I practiced enough. But typically, the way you're thrown into difficult situations are somewhat predictable in the sense like that you'll get a hard time signatures or hard harmonic changes, but you do enough of them that you sort of start getting used to it. Um, and or you can sort of know how to navigate those spaces in a way that makes it sound well,
You get an
sound good.
intuition over time.
Yeah. So one thing I like doing, so one of my paper I had last year at ICCC is trying to use generative melodic models as part of the improvisation process. So the model, the gist of it is that the model essentially hijacks your notes and replaces them with its own notes. So you no longer, you still control the rhythm, but you no longer have control over the melody that's being produced, which really drastically changes how you approach improvisation. And so I've used that live with my trio, and it worked okay. I mean, you couldn't really tell that it didn't sound terrible. I guess let's put it that way. It sounded okay, but it was really challenging, and it was really difficult to improvise with this, but in an exciting way, because it made me think about improvisation in a very different way. And so that's what really gets me excited about this stuff: is can we make artists that already know how to do things really well and have their zone, and they know how to nail it in this zone. Can we get them into a different zone where they can still do a good job, but now they're thinking of the problem in a very different way, in a very different space? And ideally, this produces new art that may not have been possible without this push from these intelligent agents. And so that's where my interest in this comes from, more as an extra tool.
Do you think, like, usually ML models are thought of as black boxes, even though we have interpretability tricks now coming up? But do you think your real world experience or your intuition is helpful for you to debug the models or to get an intuition of where things are going out of balance?
Sometimes I think also your human biases can hurt. And I think this is a general problem with a lot of machine learning, that there's a lot of anthropomorphizing that happens, and it sometimes it bugs me quite a lot when they talk about a model. The model thinks that red and blue are colors, or
Yeah.
the model found this analogy or something like that, or the model is confused by this analogy or something like that. These are all human sentiments that we're projecting onto these machines that are really just doing numerical optimization
Yeah.
over a data set. And so I think it's just a very different way of approaching problems. So when you have this trained model, the way it approaches a problem is very different than the way we approach a problem. And so, and this happened to me when I was first getting, because during my PhD, I didn't touch neural networks at all. It's only when I joined Brain that I had to catch up on all these neural networks.
Okay.
And so at the beginning, that was one of the things where I'd see things like anecdotal evidence of something the model was doing. And I'd attribute what I would expect a human to do to handle these types of problems. And so I'd search in that direction, but then it ended up being something very, very different that ended up resolving the problem, because these models are just handling these problems or challenges in a very different way than we would as human. So human intuition is obviously necessary and important and can get you very far, but I think attributing too much of your intuition to to try to understand what the model is doing can lead you astray, and can often make you tend to anthropomorphize these models more than you should. So like an example of this, which bugged me a bit, OpenAI had this blog post recently where they had these multi-agents. They had like a capture the flag game going on,
Yeah.
and they were saying that the agents figured and jump over the thing, over the walls, and so they figured out a trick, or fine, whatever. It's really just they found a set of actions, a policy that led them to the reward. They're not thinking in this way that, oh, like the fact that they're jumping over a wall is interesting to us because we don't normally jump over walls.
Yeah.
But from the agent's perspective, it's just a policy. It's one of the action choices, or a set of action choices, that ended up leading to the high reward, which is what they're optimizing for. So this anthropomorphizing of the training process, or the resulting quote unquote behaviors, is something that I try to avoid as much as possible.
I think it's also because of the marketing aspect to it. Not many people are fortunate enough to understand that it's just math running in the background, and they feel, okay, this is an AI trying to do things. So maybe it's for that, but it exists,
Yeah, for
unfortunately.
sure. There's a PR element to it, and that's why they've gotten a lot of criticism for some of the releases. And I get, like, they're a startup. They need funding. I get that, but I do worry a bit when I see a lot of these press releases that it's overhyping these things. So then you have media outlets that, yes, they don't understand that it's all just math behind the scenes, and not super interesting relative to what we were already doing 20 years ago. But then they have these amazing videos. The video production is incredible of that particular blog post.
Sure.
I was really impressed. So they pick up on this, and so they report it as AI learning how to break into houses. I don't think that was actually reported, but you know, that's the type of thing that these clickbaity headlines that media likes to pick up, and this leads to this hype that AI is. People think AI is at a state where it's not in. It's not yet at the state where a lot of media portrays it to be, and I worry just because this, I feel, inevitably inflates a bubble that I do feel we're living in right now. And when and if this bubble bursts, a lot of these smaller companies are going to be the ones that are most affected. So it's tricky, because on the one hand, I understand you want to raise funds and you want to get people excited about your research and what you're doing, and make the research approachable to people not familiarized in the field. But I also, on the other hand, you also don't want to play that card too much, because I think in the end it'll be hurtful.
The truth lies somewhere in between. Now,
Yeah.
Coming back to your research, how is this challenging? Can one not just convert music into notes, fit a language model on top of it, and they're good? What's the difficult challenge here?
Yeah, I mean, and so there's a paper by some colleagues called Music Transformer that was published in iClear last year. And it's taking a transformer model, which was from the Attention Is All You Need paper that was originally designed for language, and applying it to music. They had to change a few things in terms of how the data is represented, but at its core, it's a transformer model, and it produces amazing outputs. So recently, my colleagues released this Listen to Transformer site where you can go and listen to samples from this, and it's really cool. It's really exciting stuff. Um, so that is doable, but there are still limitations. For instance, the length of these pieces is often limited by computational capabilities. So it's not like an LSTM where you can just kind of let it rant for as long as you want. The LSTMs would tend to sort of diverge into nonsensical territory. This is a lot more coherent, but I think it does become difficult to have something that's much longer scale. The other thing is inference time. So they're still expensive to sort of generate these pieces, and you have to have typically access to specialized hardware like GPUs or something like that. And so I'm interested. One of my interests in creativity is in the performance setting. So can we use these models in a live performance setting? And that's a whole different ballpark. And so this inference lag can become really problematic. And so, but then another problem with that is these models like Music Transformer, yes, it produces really interesting melodies and outputs, but it's a single model that then everybody uses. So I have to sort of curate to find something that appeals to me artistically. So having something that's more personalized is a challenging problem because not everybody's going to be able to find their own data set and train their own model. And typically, if you have very niche taste, then the data set is going to be very small. So there is some work already by a few people, including myself and some other colleagues, in trying to develop robust ways of personalizing these generative models to adapt to specific users' tastes without necessarily having to retrain a full generative model. So there's still a lot of, even though we can already train generative models to produce really compelling music, there's still a lot more work to be done before it can become a core part of artistic creation.
Also, because music is very subjective. Some music that I might enjoy, you might totally hate, and vice versa.
Absolutely, absolutely. Yeah, it's and this is where the personalization comes in. So the data sets that they train on are typically Western music, Western pop or rock, which I'm more of a jazz person. So some of it appeals to me, some of it not as much. Or actually, the Music Transformer I think was trained on classical mostly. So it's mostly classical piano, which I really like, but
Okay.
some people might not like as much. But also, if you like, if you're from Asia, you might have different style of music that you want to explore, and not just Western music.
Yeah.
Or from South America. There's different. Even though I think the overlap is a bit greater there, but there's still like traditional folk music from South America that I probably won't see reflected in that data set. So there's a bunch of these issues of low data regimes that we still don't quite know how to handle properly yet.
One thing I'd also love to know is about the dataset curation. I know for a fact we cannot just go and scrape the US top charts because you have licenses involved. What sorts of datasets are available? And talking about frameworks, what frameworks do you use? Are you a PyTorch person or a TensorFlow person?
Well, I'm a TensorFlow person, not surprisingly. I mean, that's not. I've done a little bit of PyTorch, and I've more than coding it myself. I've been a mentor for summer schools and things like that, and often they're written in PyTorch, the training material. So I understand PyTorch, but I don't code in it. I started in TensorFlow. I mean, here at Google, obviously a lot of us use TensorFlow. Not everybody uses TensorFlow, but that's where I started when I started looking into neural nets. And so, for me, there's less friction now to stick with TensorFlow over PyTorch, but
Okay.
I know a lot of people have very strong feelings about this. For me, it's not as higher producing as for some other people. Maybe I've just gotten used to it. I don't know. In terms of data sets, that's always a challenge. I think there's a lot of open data sets out there. It really depends on what you're trying to do.
Yep.
So Magenta released this data set, I think last year as well, at iClear, which is this piano, Yamaha piano competition. So it's virtuoso piano players playing on
Yep.
a piano that's able to record their performance both digitally and the raw audio. That's called the Maestro data set. And so that's what they use to train the music transformer on. And so that data set's out there, but yeah, there's other things. So for instance, one of my projects is with lyrics, like a model that can assist you in writing English lyrics. And so that we've been using just some public data sets that are out there. There are, like, for instance, the top 40 hits over the past 6 decades. It's a data set that's public, it's open, so we've been using that. And a fiction books data set, Libre Speech, I think it's called, that has a whole bunch of books that are not bound by copyright. So there are challenges, difficulties with each of these data sets. You have to do some curation and some cleaning of the data and normalizing so that all the data is in the right format for training, these types of things. This is sort of the dirty work in machine learning. There's a lot of this that has to happen before you can even start trying to train models. And even as you train, you might find issues with your data set that in the lyrics one, for instance, we're still correcting issues in our data set as we move forward. So yeah, it's just, I don't know, kind of find what's out there, and building your own data set is hard. It's really time consuming. And I really appreciate when people do that because it's extremely valuable for the rest of the community, but it does take a lot of time, and it's potentially less rewarding than training a model and having it produce things that you want it to produce. Yeah.
Yeah. Does your research also trickle into the Magenta project? Does your team talk to the Magenta team as well?
So I'm an unofficial member, or official/unofficial member of Magenta. So
Okay.
I don't report through the Magenta reporting chain, but I know all of them. We chat pretty regularly. I sometimes sit in on the research meetings, and we have a few collaborations, but there haven't been as many as I would like. In part because they sit in California and we sit here, so the physical distance and the time zone difference does cause some friction. It's just more difficult to coordinate meetings, and if you're talking about math, like, using a whiteboard is so much easier than doing it over video.
Yeah.
So just things like that. But we are talking about new projects that would ideally be some collaboration between some people here in Montreal and some of them in California. But yeah, I mean, when I give talks, I'm both representing Google, but also Magenta, because a lot of the stuff I talk about is the work that comes out of Magenta.
Awesome. Now, coming back to research, I'd love to know, what does a research pipeline for you look like? Many people aren't sure what does a life in a researcher's day look like, and how do you approach new problems? You said you work on multiple problems in parallel. Let's say you find an interesting idea that you want to work upon. What are your steps when you're getting started on a newer idea?
So I have a lot of ideas. I mean, like most people, some are more difficult to get started with, in the sense that maybe you need a special data set that you don't have right now. So the first step would be build a data set. And that immediately would, for me, be reducing the priority of that project, because that's something I'm not super interested in doing right now. But keep it in the back of my head, because maybe a data set comes up that's exactly what I need, and it's like, oh, great, now I can actually tackle this problem. But yeah, so some ideas come from reading books that often are not machine learning related books. And sometimes the ideas that end up happening are not necessarily machine learning related. So I had this website I made that was exploring evolutionary algorithms, but not with the sole purpose of surviving, but there was an element of aesthetics embedded into it. So there were these little things that kind of looked like birds, and they had colors. And so the females preferred really colorful male birds, But male birds, the more colorful they were, the shorter their lifespan. So it took them longer to find a mate, and they might just die. And so this dynamic playing with that was pretty interesting, and it ended up producing this thing that I found it was quite artistic in the sense that it was very aesthetically pleasing, and it was a dynamic and moving. You had these things moving around in different colors, and it was really nice to look at. That idea came from reading this book on it's called The Evolution of Beauty by Richard Crumb. So it has nothing to do with machine learning, but that sparked an idea, and I like those types of ideas because when I think of them, if sometimes I can already imagine how I would write code for it to like reproduce the idea in a very simple scenario. And that's the type of problem I like to start with, where I can immediately start running some simple experiments to get a sense for what's happening. And the same goes for reinforcement learning. So in reinforcement learning, it tends to be, the ideas tend to come more from as offshoots of problems I'm currently working on. So this work with representation learning, this actually, I can't remember exactly where it came about, but it was more as a consequence of another problem, that another paper we were thinking of. I think it was yeah, we had a paper in AAAI last year on trying to understand distributional reinforcement learning. And I think from there, I started thinking about representations more. But in those problems also, I like to start with grid world or toy problems before going into the deep setting, because I find it's a lot faster to run experiments. The visualizations are a lot cleaner in the sense that you can compute the optimal value function exactly, and then you can directly compare against that, and you can generate visualizations and animations very easily that allow you to really understand what the algorithm, before you start throwing neural networks into it, is doing. Once I have that kind of as a proof of concept, then I start trying to tackle the neural network for larger problems. But I like to have this proof of concept or toy world reference point that I can point to. And often, like, I like things that have theory to them. So I'll often, when I'm starting a project like that, try to come up with some theoretical basis or theoretical motivation or justification for what I'm trying to do, and then build the algorithm on top of that. So the algorithm isn't just built on some creative idea. I mean, there are a lot of cool algorithms that come from that, but I really like algorithms that come from like a theorem or something. So in this scenario, this algorithm is proven to converge and it has, say, great sample complexity. In practice, we're going to loosen some of those requirements for the theory to hold, but at least it has this connection to the theory. And so then once you get into the deep networks, then you have this issue of trying to find the right hyperparameters and making sure you're comparing against the right baselines and making sure you're optimizing the baselines and that type of thing. And often writing the code, especially for deep networks, surfaces some problems that aren't problems in the theoretical situation.
Yeah.
And yeah, that's kind of how I approach these things. I try to start from simple to convince myself that there's merit in the idea, and then try to scale it up.
Got it. Now, coming to another aspect of future aspiring researchers who are taking up MOOCs, who might not have been fortunate enough to do proper education.
Mm-hmm.
What advice do you have for them, people who are using MOOCs to educate themselves but aspire to be researchers in the future?
I think MOOCs are great. I think we live in a really exciting time where there's a lot of resources out there for people to learn from and be self-taught. One thing I would, it's funny because 2 nights ago I was out for dinner with some people, including my ex-supervisor, Doina. And one thing we were talking about is that because there's so much emphasis right now on deep networks and the power of deep networks, I think a lot of people getting into the field often forget or don't realize that all of this stuff has been around for decades. I mean, neural networks are from the 1950s. There's a lot of work that from the 1980s that people are using now. This is old stuff. It's just now we have more compute, and yes, there's new algorithms, obviously, but it's has a long trajectory, and all the people that the Turing Award winners like Jeff Hinton, Yoshua Bengio, and Jan LeCun, I mean, Jeff Hinton was working on energy-based models, which not many people are looking at anymore. Uh, and so there's a lot of core machine learning and core math that is really important, I find, to make a really strong researcher. And because there's so much emphasis right now on deep networks, I one thing that we were chatting about 2 nights ago is that we fear that a lot of young people want to sort of bypass all of that and jump right into the exciting stuff, which is training deep neural networks, which is fine. I mean, like maybe that's just fine. But I would say that there's a lot of value in studying the core, the heart of where all this came from, which is like in RL, for instance. Like there's a lot of things you have to learn before you even think about neural networks. Just the Bellman equation and temporal difference and things like SARSA, all these algorithms that are from way back in the day that are still being used now, but if you understand them well without deep networks, you're going to have an easier time understanding them when you start trying to apply deep networks to them. Yeah, so as an example, we had an AI resident last year, Carlos Salada, and he actually dropped out of high school and was self-taught, and but he really taught himself from the start, from the basics, and he had a really strong. He's very good at math, so he had a really strong mathematical foundation for what RL is, and then applying it to deep RL, he had some really good results. So he had a AAA and an ICML paper, and now he's with OpenAI. So I think part of the reason why he is able to produce such great results is because he understands the core of where all of these deep results are coming from.
Okay, awesome. Another thing that I'd love to know more about, and unfortunately I hadn't heard about this, LatinX. I know you're very active in the community. Can you tell us more about it? Because I assume many people like me are totally unaware of it.
Yeah. So essentially it's an effort to try to increase the representation of Latin Americans in the AI research community. And a lot of it is inspired from the work that the people at Black in AI have been doing for the same reason, to try to increase the representation of Black people in the AI research community. So I was at ICML in Stockholm in 2017, and they have these Hova apps where you can create chat rooms and meet with people, etc. And so somebody created a chat room, LatinX, at ICML.
Okay.
So I joined, and a bunch of us joined, and we said, let's meet for lunch someday. So ICML is like 8,000 people. And so we met or at least that year it was about 8,000 people. We met
definitely
for lunch.
More now.
Yeah. We met for lunch and there were 20 of us. So 20 Latin Americans out of 8,000. So it's like, okay, there's a problem here. Like we're not really well represented. And all of the people that were there, all of us that were there, we don't live in Latin America. We live in the US or in Canada or in Europe. And we work for companies like Google, or we're professors at universities. We're not in North America or in Europe. I don't think there was anybody that was living in Latin America and pursuing their career in Latin America. So that we were wondering, like, why is that? Why aren't there more Latin Americans here? And so there were a few efforts that sort of started around the same time. There was this organization, LatinX and AI, this coalition that had already been started. And so I reached out to them and offered to help. And so they had already been accepted to have a workshop at NeurIPS. So that would be a Latinx and AI workshop at NeurIPS. And so I helped with the organization of that first workshop. And essentially the idea was to try to get people from Latin America, not exclusively Latin America essentially, but really one of our main motivations was to try to get people from Latin America to present their work at this workshop. So we went through a review process and we got sponsorship. So we were able to finance like all of the people that had oral presentations. We paid 100% for their trip, their lodging, their registration, and I think 50% for posters. And it was really amazing because that revealed that there are many problems and many reasons why Latin America wasn't represented. One is finances, so it's really expensive to get there. Two is just visibility. I mean, the research that they're trying to do might be more limited to their local areas, and maybe they're not submitting, or maybe they're not playing the game right, in the sense of trying to get these papers into the main conferences like NeurIPS or ICML, or maybe they don't even want to try because it's so expensive. Maybe they're lacking hardware to be competitive, so that maybe they don't have the right GPUs, that type of thing. And so it was a huge success. We had a lot of people come. People were super grateful for this, and so we've continued doing this. We did it again at NeurIPS last year. We did it at ICML last year, and we're doing it again this year. We've had a few more informal gatherings. So at AAAI, I organized this lunch sponsored by AAAI, and it's also gotten a lot of companies interested in it. So Google has been really supportive of this. They've both as sponsors and supporting me traveling to these events and helping with the organization. They've been extremely supportive. At AAAI, Google hosted an event that was for Latinx and Black in AI, and that was extremely useful, and people found great value in it. So that's kind of the gist of those efforts. And there are other efforts besides Latinx and AI. So Kipu happened last year in Montevideo. It was like a summer school, so we had Nando de Freitas, Kyung Yoon Cho, Chelsea Finn. We had a lot of, Jeff Dean came, Joshua gave a talk, I think, over video. There were a lot of like the big names there giving lectures. I was teaching some practicals on transformer and reinforcement learning, so just the community building that happened there was really exciting. There's also RIA, which happens in Mexico in August. So I was there last year, and I'm likely going again this year. It's part summer school, part conference. There was a event at MIT a month ago that I was there. That again is trying to foster this community of Latin Americans in research and in AI research specifically. So that's kind of a long answer to to your question.
So for an outsider, and I want to use this advice as a proxy for other underrepresented communities as well, how can an outsider, like for example me, contribute to such communities?
So there's a few different ways. We have, well, the easiest is probably if you're a researcher, you can help with reviewing. So we have a call for reviewers, a call for papers, and so people submit papers, and the more high quality reviewers that we have, the better. Not just in terms of, the emphasis is not so much in filtering out papers, but in providing good feedback to the people submitting. So maybe that's why they're not getting into the main conferences, because they're not getting the right feedback. They're not being guided into how to write a proper research paper. These types of things that sometimes it just takes one sentence from like a very senior researcher, a very experienced researcher, saying like, this is, you don't do this. And so we do a lot of these things. Black in AI, for instance, had a thing last year that I thought was really cool, that the people that were accepted to present posters, they would pair them up with mentors. So they could send their poster to their mentor, and the mentor would give them feedback. So I did this for one person, and they sent me their poster, and so I gave them a bunch of suggestions for how to make the poster more effective and more appealing to try to get people to come talk to them more. There's even organization committees. So each year we have a different organizing committee for setting up. It's a lot of work to set up these conferences, everything from sorting out visas to sorting out the meal logistics to sorting out sponsorships, a program committee for sorting out the papers. All these things take work, so you can volunteer there. And then just in general, like keeping your ears open, even just if something comes up that you feel like perhaps would be a good opportunity for showcasing some of these efforts, like not just Latinx and AI, but Latinx or Black in AI or queer in AI. And sort of, if you know people that are involved in the community, say, hey, you might want to check this out, or you might want to contact Pablo for this Latinx proposal. There's a whole bunch of, basically just, there's a whole spectrum of how much you're willing to put in, and any type of help is always really welcome.
This is me slightly going off on another tangent, but now that you mentioned it, many people miss out on this fact that usually the community rewards the best talent for good reason. And like you mentioned, many people don't aim for the best conferences because it's completely out of their reach also, even though they might have the skills or the brains, but yet they're not able to contribute to it.
Mm-hmm. Yeah, absolutely. And maybe it's just a question of presenting at like a workshop, which is a bit less selective than the main conference. And there you meet with researchers that maybe just, all it takes is like one famous researcher to tell you, this is really cool stuff, you should submit it.
Yeah.
And then that's enough encouragement. So there's huge value, I find. One of the main things I like about these conferences is the person-to-person communication, which is just, you at least for now, you can't get it from video, you can't get it from email. There's an immense value in that, and I think a lot of the more junior people or people that are not yet really in the community, the feedback we've gotten is that they get immense value from having more senior people approach them and talk to them about their research and sort of spend some time with them.
Awesome. Now, before we conclude the interview, if you were to give one best advice to future aspiring researchers who are maybe trying to automate their music creativity or otherwise, what would that be?
I think follow your passion. So I had to leave research for a while because I just couldn't get a job. But I never stopped doing music. I never stopped reading. I stopped reading academic papers, but I still was, coding my own experiments. And 5 years later, I was able to rejoin the research community. But not because that's what was popular, but because I was always really passionate about that. And so there's a lot of things that are really popular right now that maybe you're really excited about, but if you're really excited about that, cool, but follow that path because you're really excited about it, not because it's popular and you think that it'll get you published at NeurIPS or it'll get you a job. Because research is hard. It's a really long game. There's a lot of failures. You get rejected so many times from conferences or from whatever. There's just a lot of downsides, not downsides, but there's a lot of failure moments that it's not roses out the whole way. There's people you compare against. Competitiveness is still an issue, even though we try to reduce it, but it's inevitable that you compare yourself against the person next to you or the person who graduated the same year as you that now is doing much better than you are from the surface, which is not necessarily the case. There's many aspects to success that go beyond your H index or how much money you make. My original plan was to be in academia. When I had to leave, yes, it was sad, but I still had an amazing job. I still had really challenging problems to work on, had a great family, had a great life. So I was really happy. Yes, I couldn't do research, but that's fine. So don't be, I guess, follow your passion and don't be discouraged if it doesn't necessarily work out immediately.
Before I end the call, what would be the best platforms to follow you and follow your work?
Twitter.
Can you shout out your handle? Because I know some people are too lazy to scroll to the show notes.
Yeah. So it's PCASTR. So okay. Pcastr, PCASTR. I'm pretty active on Twitter. I occasionally check LinkedIn, but I'm hardly ever. And Facebook is more for just like personal things. So for research stuff, it's really Twitter.
Thank you so much, Pablo, for joining.
Thank you for inviting me. This was fun.
And thank you so much for all of your research and contributions to the LatinX community.
Thank you for this podcast.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.